Hello friends, welcome to Susan and John MathTube. In this video, we're going to learn an awesome method to solve differential equations, and that is our power series method. Remember the methods you might have learned to solve differential equations in your high school and in previous semesters. In all those methods, you will get your answer as functions. But here we solve, but our answer will be, as the name suggests, it will be a power series. Or rather, our answer will be in the form a0 plus a1x plus a2x square plus ... to infinity. And case 1, that is what we are going to learn today, will exist only if x equal to 0 is a non-singular point. Okay, I'll give you an example. Suppose you have a differential equation x into dy by dx plus y is equal to 0. Clearly, the order of the differential equation, order means you should look at the derivatives and find the one which has been differentiated maximum times. Here we have only dy by dx, so the order is 1. Now look at the coefficient of dy by dx. Okay, and then what you do is you divide throughout by that coefficient. So dy by dx plus 1 by x into y equal to 0 by x, that is 0. Now what you do is you inspect term by term and check whether x equal to 0 will make any of the terms infinite. Yeah, so that means x equal to 0 is a singular point. This is one easy way to check whether the points are singular or not. I'll give you another example. X square into d square y by dx square plus x into dy by dx plus y equal to 0. The order of the differential equation is 2. Now what you do is you divide throughout by x square. So we get d square by dx square plus 1 by x into dy by dx plus 1 by x square into y equal to 0. Now you inspect term by term. Term means separated by plus or minus. Okay. When you put x equal to 0, this becomes infinity. When you put x equal to 0, this becomes infinity. So we say x equal to 0 is a singular point. Okay. That is point number 1. So remember, a power series solution. Look at this. There is a reason why we call it a series. Series means infinite summation. Can you see plus 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 dot up to infinity? And we call it a power series because it is made up of powers of x. X to the power 1, x to the power 2, x to the power 3, etc., etc. And the condition for existence is x equal to 0 should not be a singular point. I'll give you one example for that and then we will start. So look at this differential equation. The order of this differential equation is 2 and the coefficient is 1. That's it. So I'm not going to do anything, and it's clear that when I plug in x equal to 0, no terms will become infinity. So here x equal to 0 is not doing any harm. So it is a non-singular point. I'll give you another example. 1 minus x square into d square y by dx square plus 2x dy by dx plus y equal to 0. Okay, the order is 2 and the coefficient is 1 minus x square. So I'm going to divide throughout by the coefficient of the highest order. So I end up with 1 minus x square plus 1 by 1 minus x square into y equal to 0. Okay, now look at this. It's clearly visible that if I plug in x equal to 1 or x equal to minus 1, we will get infinity. But x equal to 0 is a harmless person. I mean, harmless in the sense it's not going to make these terms infinity. So here also x equal to 0 is non-singular. Okay, so I'll come to the point again. Today the method we are going to learn is called power series method. That is, we are going to assume that a0 plus a1x plus a2x square plus dot to infinity to be the solution of the given differential equation. And then we find a0, a1, a2, etc. Condition number 1. X equal to 0 should be a non-singular point. Okay, and something to notice, we call this a series because it is an infinite summation, and it is called a power series because it is written in terms of powers of x. Okay, now second thing, suppose I have an equation. You must understand that the solution is the quantity. The solution is the value of the unknown. Look at this. In this equation, x is an unknown. In this equation, x is an unknown. So, the value of x which can balance this system. See, if I plug in 1, I get the system being balanced. Or let's say 1 satisfies the equation. So 1 will be called the solution. So the solution of an equation is the quantity or quantities which can be used instead of the unknowns in such a way that the equation will be balanced. Another example, we have a quadratic equation. And I know that 2 and 3 are the solutions. Because 2 and 3 are the only numbers which can be substituted instead of t, that will balance my equation. So look at this, I get 4 plus 6, 10, 10 minus 10 is 0 equal to 0. 3 square minus 5 into 3 plus 6, so 9 plus 6, 15 minus 15 equal to 0. Now let's try to solve one problem. So you can join me, you can write solve dy by dx equal to y. Now remember, the solution of a differential equation is the value of y which will be written in terms of x. Like we had numbers for the linear equation and quadratic equation, in differential equation the answer will be a function. So the function which will balance the system is called the solution. And remember, there will be infinite number of solutions, and we always try to find the most general solution. And one more important thing, a first order differential equation will end up with one arbitrary constant. And a second order differential equation will end up with two arbitrary constants. Anyway, let's try to solve this differential equation using power series method. Okay, the first thing to do, you assume that a0 plus a1x plus a2x square plus dot to infinity to be the required power series solution. You just believe that this is our answer. You just believe that this is the answer. So we assume that this is the required power series solution. To make things a little bit comfortable, I'm going to convert this into summation format, sigma format. Now look at this. I can write the same thing as sigma k equal to 0 to infinity ak x to the power k. Now remember, sigma stands for plus addition. and this k equal to 0 to infinity, the limits or the counter of the summation, it will keep on supplying numbers for the counter, for the value of k. And together this plus and the counter will create this summation. Look at this. When I put k equal to 0, we get a0 x to the power 0. X to the power 0 is 1. Then our summation will shout plus. Now I put k equal to 1. So a1 x to the power 1 plus a2 x to the power 2 plus a3 x to the power 3 plus. So it goes on up to infinity. Anyway, what I am trying to convince you here is the quantity inside this yellow box and this are the same. Now look at this. The principle I am going to use here is very simple. I am going to claim that this is the solution. So the solution must balance the equation. I told you, solution means the value of y, which will be written in terms of x, or a function in x. See, I am assuming this to be the solution. And I know that this will balance the equation. But to make things comfortable, I am just writing everything in sigma format. And I notice that I want dy by dx. So look at this. When I find dy by dx, let's try to find dy by dx from here. When you differentiate, the first term will disappear because this is a constant. And that means our summation will start from k equal to 1 to infinity. And it will be nothing but ak k x to the power k minus 1. Just differentiate this part because that's exactly what's going to happen. a1 into 1, a2 into 2x, a3 into 3x square, a4 into 4x cube. Look, we created the same effect. When I plug in 1, it will be a1 into 1 into x power 0. That means a1 plus when I plug in 2, I'll get a2 into x to the power 2 minus 1. Now what we do is, we will plug in this and this inside the equation. So we have to write something. Since the solution will balance the equation, since the solution will balance the equation, balance or satisfies. So look at this. How did we start? We assumed as if we know the answer. We pretended as if this quantity inside the yellow box to be the answer. And that's exactly the same thing over here. Okay, so I'm going to plug in everything in the equation. So instead of dy by dx, I'm going to write this. So I'll get sigma k equal to 1 to infinity ak k x power k minus 1 is equal to, now the right side of the equation is y and y is this. So sigma k equal to 0 to infinity ak x to the power k. Okay, now don't forget our aim. Our aim is to find a0, a1, a2, a3, a4, a5 up to infinity. Okay, so that's the next thing to do. Now look at this. There are infinite number of terms on the right and left. Because when you plug in 1, you get the first term. When you plug in 2, you get the second term, and you are allowed to plug in up to infinity. So there are infinite number of terms in the right as well as left. So what I am going to do is I am going to create a general term. So I am going to write equating coefficients of x to the power r on both sides. So you will notice one thing. When I plug in 3 instead of k, the power becomes 2. When I plug in 37 instead of k, the power becomes 36. Anyway, I am interested in the power r. I want x to the power r. I am wondering what should I plug in for k so that the power will become r. The method is very easy. Right now the power is k minus 1. So I am going to write that so that you can see very clearly. I want the power to become R. That means I should plug in K is equal to R plus 1. Just take it to the other side. Okay, so I'm going to plug in K equal to R plus 1 wherever I see K. So A R plus 1 times R plus 1 is equal to, now look at this, this is another summation and the counter is different. Now I look at the power. Oh, the power is K. I want the power to become R. That means I should plug in K equal to R, obvious. So I'm going to plug in R. Okay, that's it. My job is done. Okay, now what I do is I'll write the bigger subscript in terms of the smaller one, and writing like this is called creating reduction formula. Now what we do is we put R equal to 0, that means 0 plus 1, A1 equal to A0 by 1, that is A1 equal to A0. Now what I do is I put R equal to 1. When I put R equal to 1, I get 1 plus 1, 2. And the right side will become A0 by 1 plus 1, 2. That is A2 equal to A1 by 2. But wait a minute, what is this A1? A0. Now I'll put R equal to 2. When I put R equal to 2, I get 2 plus 1, 3. And I'll get A2 by 2 plus 1, 3. But this A2 can be replaced with A0 by 2. So I get A0 by 2 into 3. That's more than enough. I hope you did not forget your aim. We assumed this to be our answer, right? Let this be the power series solution. Now I'm going to plug in everything here. I found A1, I found A2, I found A3, etc. etc. So I'll plug all those values and that will be my solution. So I'm going to write the required solution is A0 plus A1 into X. But A1 is A0 X plus A2. A2 means A0 by 2 into X square plus A3. So A0 by 2 into 3 into X cube. And it's pretty obvious that the next one will be 2 into 3 into 4 into X to the power 4 plus etc. 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 Okay, so the answer will be A0 into 1 plus X plus X square by, I can write 2 as 2 factorial because 2 factorial is 2 into 1, which is 2, plus X cube by 3 factorial plus X to the power 4 by 4 factorial plus, that's it. So that's it. We have our solution, but it is in terms of a series. And this method is called the power series method. Anyway, I'll be back with more problems in the next video. So till then, bye.